All right, let's talk about something that every single programmer runs into. I like to call it the code apocalypse. You know exactly what I mean. That moment when your brilliant little project starts to turn into one single massive, totally unreadable file. Well, today we're going to dive into Python's super elegant solution to all that chaos, modules and packages. Seriously, if you want to build code that's clean, powerful, and reusable, you've got to get this down. Let's get into it.
We have all been there, right? A project kicks off, it's so clean, so simple. Then you add a feature, and then another one. And pretty soon you find yourself just scrolling and scrolling and scrolling through one giant script. It becomes this tangled mess that's nearly impossible to navigate. So, how do we break out of this one-file nightmare?
The root of this is what we can call the one-file problem. When every single piece of your code lives in one script, it's like taking all your tools, your notes, and your blueprints and just throwing them into one big pile on your desk. For a tiny little project, maybe that's fine, but it very quickly becomes a major headache.
Yeah, this whole approach creates two huge problems. First off, maintenance is a nightmare. Trying to find one little bug means you're digging through hundreds, maybe even thousands of lines of code that have nothing to do with it. And second, you completely lose reusability. You know that awesome function you wrote? If you want to use it in another project, you have to copy and paste it. And let's be honest, that's not just clunky, it's a surefire way to create new bugs.
So the first step to getting organized is the module. And the best way to think about a module is as your first toolbox. Instead of having all your tools jumbled up in one big pile, you create a dedicated toolbox for a specific job. You've got one for your wrenches, one for your screwdrivers, and so on. It's all about specialization.
And you know, the official definition is just that simple. A module is literally just a Python file, a file with a .py extension. That is it. Any Python file can be a module, and inside you just store your related functions and variables, your tools for a specific task.
Okay, let's make this real. Here we have a file called fibo.py. Inside, we've put two functions that are both related to Fibonacci numbers. And just by doing that, by creating this one file, we've made our Fibonacci toolbox. The file itself, fibo.py, is the module, and the functions fib and fib2 are the tools waiting inside. So, you've done the smart thing. You've organized your functions into a module, a toolbox. That's fantastic. But how do you actually get those tools out to use them in your main project? Well, the answer is the import statement. This is the key that opens your toolbox.
And there are two main ways to go about it. Over on the left, import fibo is like grabbing the entire toolbox. To use a tool, you have to say which toolbox it came from, like fibo.fib. This is awesome for keeping things clear and organized. Then on the right, from fibo import fib is like reaching into the toolbox and pulling out just one specific tool. Then you can use it directly, just by calling fib. It's a bit more direct, but you can sometimes lose track of where that function actually came from.
Now, a quick but very important warning. You might see code out there that uses from fibo import star. That little star means everything. This command is like taking your toolbox, popping it open, and just dumping every single tool out onto your workbench. It is messy, and it makes it really hard to tell where each tool came from, which, as the official docs say, just leads to poorly readable code. So, bottom line, be specific with your imports.
Modules are fantastic, but as your application starts to grow, you might end up with dozens of these toolboxes just cluttering up your workspace. You need a bigger level of organization. You need a workshop to put all your toolboxes in. And in Python, that workshop is called a package. At its heart, a package is just a folder that contains other modules and even other folders, which we call sub-packages. It lets you group all your related toolboxes together. That dotted module name you see, sound.effects.echo, is like a clear address. Go to the sound workshop, find the effects room, and grab the echo toolbox. It's a perfect path to the exact tool you need.
And this structure is really intuitive when you see it laid out. The sound directory, that's our main workshop. Then inside, we've got separate rooms for different jobs. A formats room for file conversions, an effects room for, well, sound effects, and a filters room. Each one of these is a sub-package, its own folder with its own modules inside.
But what about that init.py file? This little file is the secret sauce. This file, even if it's completely empty, is a special signal to Python. It's like putting a sign on the folder's door that says, hey, this isn't just any old folder, this is a Python package, a real workshop. Without it, Python will just ignore your carefully organized structure.
So let's stop and ask a pretty basic question. When you type import my module, how does Python have any idea where to look for that file on your entire computer? It doesn't just scan your whole hard drive. That would take forever. No, there's a very specific logical process it follows, and it's called the search path.
Python basically has a checklist of places it looks, and it does it in a specific order. First, it checks the folder where your current script is actually running. If it's not there, it checks a special list of folders that you can define in something called the Python path. And if it still can't find it, it looks in the default spot where all of Python's own standard toolboxes are installed.
Now, this entire checklist, this master map of all the places Python will even bother to look for code, is stored in a list called sys.path. And here is the key thing to remember for troubleshooting. If you ever get that dreaded import error module not found, it just means one thing. The module or package you are trying to use isn't in any of the locations listed in sys.path. Your workshop isn't on Python's map, and you just need to figure out why.
So we've gone from a messy, single file all the way to this beautifully organized workshop full of packages and modules. Why go through all that trouble? Well, the payoff is absolutely huge, especially as your projects get bigger. This is really the difference between a little hobby project and a professional application.
Your code is now organized and logical. It's maintainable because bugs are now stuck in their own little files. It's reusable because you can just import your custom toolboxes into any project you want. This structure also makes it way easier to work with other people, and most importantly, it gives you the foundation you need to scale your ideas into much bigger and more powerful applications.
By mastering modules and packages, you've really moved beyond just writing lines of code. You're now an architect, someone who can design and build clean, efficient, and scalable software. Your project is now a fully equipped workshop, so the only question left is, what amazing things are you going to build in it?